numerators, which is, we add our numerators, which will be 4 plus the 2, and that's how we shall come up with 6 out of the 8. Okay, now some people simplified it further, which is okay. So when you simplify it further, you reduce by 2, we have 3, by 2, we have 4. So that's why we have 2 answers here. Some people are having 3 out of 4, while others are having 6 out of 8, which is good. Okay? Which is good. So, unless someone, Bironji, do you have something to ask? Bironji? Bironji? Bironji, your hand is up. Okay, Mumbere? Mumbere, your hand is up. Okay. People are just raising up the hand. All right. So, class, this is what we basically try to work out in our previous class. Now, today, we are still continuing with our manipulation of our fractions. We said last week, this is just a review for those who are not here. We're trying to add the fractions, and in our fractions, we worked out different numbers, and of which we said when you have fractions with the same denominator, maintain your denominator, and then you add the numerator, which will have, for example, 1 plus the 3. Okay, so here we will come up with 4 out of the 5. Please, you can simplify if you can. If the number can't be simplified, please, you leave it as it is. Okay, that's a key thing that we also need to get to know. Okay, so after the additions, we did the addition of fractions with the same denominator. That's what we did. This is what we did last time. We said, like, it means that, for example, if you have one piece, if you have, for example, one hexagon, as it is here, and then you divide it into 6 pieces, this is the division. And when you divide it, this is what you get. So if you pick out some, each of these, we said it is 1 out of 6, 1 out of 6, 1 out of 6, each of them. Okay, so meaning when you total them, all of them, you will come up with the 6 out of 6. All of them, they're 6 out of 6. So this is what we looked at in our previous class. This is not new. Now, in today's lesson, I want us to see what happens when you add fractions with different denominators. I tell A56. Is there something you're asking? Noel? Noel? Can you unmute and then ask? Yes, Noel? Noel,
I will just give you the answer. I will give you the answer.
Oh, you're giving the answer? Okay. Thank you.
Yes.
All right. So we are saying that what happens when you have fractions that are having different denominators? What do we do in such a case? Now, all of us at one point we've looked at what we call the LCM. Now, when you have numbers with different denominators, we utilize this rule of the LCM. Most cases, we also call it LCD. LCM stands for lowest common multiple, while this one is the lowest common denominator. Okay, this is the lowest common multiple. This is the lowest common denominator. Okay, so that is what we are using. Those are the principles we are using. But I'm going to guide you through a very simple method, or very quick method that you can use so that you can come up with your answer very fast. Okay, so Okay, so we are here. So when you have such, when you are working with the fractions with different denominators, we apply the knowledge of LCM. That is the knowledge we apply. Now, I want us to have, for example, when we have this, I'm giving you the shortest method that you can use to come up with this one here. Okay? The shortest method that you can easily come up with and answer here. Now, remember, these ones do not have the same denominator. The denominators are quite different. So meaning we cannot work it out as before, whereby you total, you add that, you take the denominator and then you add the other ones. No, you cannot do that. So what you do, now what you can do, you try to make these denominators the same. Try making these denominators the same. So how do you make these denominators here the same? That is the challenge. This is what we need to do. We make these ones here to be the same, and then we go back and use the other method of adding the numerators and then maintaining the denominators. Take an example. If you would like to maintain this one here, we need all of them to have the same denominator. What we do, using the knowledge of equivalent fractions, okay, whereby, remember when you keep reducing down, there is a way the fraction becomes. So we use the knowledge of equivalent fractions and we make this one out of 2 like this. So if we need to make this one here the same as this other one here, so meaning you get these 2 multiply to this other side, this one times 2, and then the 3 multiplies this other side, this one we say times 3. Now, at the end of it all, you'll come up with the same denominator. You know that we are seeing this. I repeat, we are using the knowledge of equivalent fractions to try to ensure that we come up with the same denominator. So you get the denominator this other side, multiply it with the other denominator, and also the one this other side, you multiply it with this one. So meaning the 2 will be multiplied by the 3, and the 3 will be multiplied by the 2. So you will come up with, this is why you have 3 out of 6, this other side, and also this way you will come up with, so we get the other one also, this 3 also, this one will also get, so it will be now plus, so you multiply times 2 up, also times 2 down. So you multiply both up and down, okay? Both up and down. So here you will come up with your 2 out of the 6. After getting it like that, well, you now utilize the other method of maintaining the denominator as 6 and also adding up the numerator, which will be 3 plus 2, which you will come up with 5 out of the 6. I repeat this. Step number 1, get the numerators, multiply them by themselves. If this is 3, multiply with the other numerator, multiply it by 2, both up and down. Then if this is 2, multiply it with the other numerator, so with the other, sorry, denominator, the other denominator, which is 3, multiply it by 3, both up and then down. Why are we doing this? To ensure that we have the same uniform denominators. When you have the same uniform denominators, you will be able to now add the numerators directly. Okay, let me answer some questions on this. Let me start with the Mavis. Mavis, can you mute and ask? Okay, Mavis is not there. Chirabo? Chirabo, can you unmute?
Excuse me, teacher.
Yes.
What if I don't want to use that method and instead of saying 1 out of 2 times 3 out of, okay, like multiplying the denominator both sides, what if I look for the the lowest common factor of 2 and 3. Will I be
Which
will I
is
be
okay.
long?
It is very, very fine. It is very, very fine. It is very fine, Travel. Now, we know that, I know we all know how to get the LCM. By now, the lowest common multiple. We all know how to get it because I know we all know that method very well. I was teaching you another method which you can also use. You can also get the LCM of 2 and 3, which is 6. When you divide 6 by 2, you get 3 times 1. You can remain with 3 plus 6 divided by 3, you get 2. 2 times 1, you come up with 2, which will still come up with what? With the 5 out of the 6. You're very correct. Okay, you're very correct. So the yes, sir?
Yes, teacher, I'm saying, teacher, hello.
Yes, please.
Yeah, I'm saying that if you get half times the LCM, which is 6, you bracket them plus 1 out of 3 times 6, and then you divide them by 2, it's 1, then by 6 is 3, then by 3 it's 1, then by 6 is 2.
Go through.
Then you get that.
Soze?
Pardon?
And
See, I'm hearing you.
Yes, start afresh.
Yes, I'm saying, what if you get the LCM? You get a half times the 6, the LCM, and then you divide them by 2, it's 1. Then 3.
This is 1.
You bracket them.
3.
Yes, then you bracket them plus into brackets 1 over 3 times the 6. You divide them by 3. But you divide them by 3, it's 1. Yes, by 3 it's 1. Then by 6 it's 2. Then you get 1 over, you get 1 times 3, which is 3, plus 2 over the 6. You get 5 over 6. Pardon?
Where are you getting the bottom 6 from?
The bottom. Nanti, you divide them by that bracket, you divide it by 6.
Now,
those brackets you have made.
You again divide them by 6, eh? All of them again out of 6.
Yes, out of 6. Then you get that 3 plus the 2 over the 6. You get 5 over 6.
Good. Okay.
Yes.
Now, about Sozi's concern, why we are not using this method here is because some people are going to forget to put the whole bit out of 6, and it is quite even longer coming from. And when you forget to put it out of 6, it means you're going to get your answer as 5. So we advise 2 methods. Okay, we advise that you use 2 methods. Either you use the LCM, okay, or you use this part of making the denominators the same, and then you add them, okay, which is okay. Okay, so this is done. Adila, Treasure. Yes, Treasure.
Are you here?
Treasure, are you there?
Yes.
You're asking something?
I want to contribute.
Yes, please do. Yes.
Let's ask whether you can use of saying that 1 half plus a third is equal to 1 times 2 in brackets.
Sorry.
Plus 1 times. The method of using, I would prefer this method. Use a half plus a third plus a third.
Plus a third. Is equal to
1 times 3.
1 times 3.
Plus 2 times 2.
Plus
1 times
2.
3 in brackets.
Plus 2 times 3.
Then out of the 2 times 3.
Out of 2 times the 3.
3
Mhm.
in bracket.
These ones are also in brackets. Mhm.
Then that
So
is
this,
3 plus 2.
you say this is times. This is 2 times this is 6,
Yeah.
right?
2 times 1 is 1.
You said 1, eh? This is what?
Yes.
Mhm.
Yes.
So
Then
this
it's
will be
equal to
5 out of 6,
3 plus. Yes.
which is this. Thank you, Treasure. Okay, so class, the point is we have several methods we can use to come up with this. But as we are looking for the methods as well, we also look out for the one which is the shortest, and it is easy to tell someone, okay? It is very easy, and then you can as well explain it to someone. So there are methods of also, someone told us they use a method of cross multiplying, okay? Those are all different methods that we can use. You can use cross multiplication, and even this one which Treasure has given us as well, and so many others. But the point is, you need to get a method which is going to simplify your work, and you're going to explain it to someone easily, and they will understand. Very good. Let's try to check on another. So when we have that, that is what we've just done. Now, we've added fractions. We are still adding fractions with different denominators. We said we are applying the LCM knowledge. Now, let's move to the bit of subtraction. We've seen addition. So members, before we leave addition, we are saying when you are adding, you have different methods. One is the LCM, maintaining, of course, everything is lying around the LCM, the lowest common multiple, or the lowest common decimal. Okay, so all these ones here can help us come to the same answer. Someone was also using cross multiplication. Okay, you can cross multiply. It is also something that you can use. Our point is, let us get all possible methods to ensure that we come up with the correct answer. But take note of that when you are doing all those additions, ensure that you don't use the other one for the same denominator. Separate the two. Separate the two methods so that we can work it out very well. Logos Joanita's hand has been up for some time. Joanita? Yes, Joanita?
I have just joined us. Which topic are we on?
We are on the topic of fractions. We are on the topic of fractions. Got it? Good. Namubiro? Namubiro? Namubiro's hand is up? Okay. Not yet there. So class, that is what we are doing as well. Okay? Let's try to do something else also. Okay? We are continuing with this. Now, after addition, there is also subtraction. Now, we can also subtract the fractions that are of the same denominator as well. Now, we use you see when you are subtracting fractions with the same denominator, use the same method with addition with the same denominator. Use the method of addition. Okay? The way we added when we have the same denominator is the same way we are subtracting using the same denominator. The only difference is we are putting the minus sign instead. We are subtracting. we use the same principle when we're adding. Okay, we use the same principle. For example, if you have something like this, I'm going to request a Opio Isaiah. Opio Isaiah. Hey, you've gone already. Isaiah, are you there? Yes, Isaiah. Isaiah? Isaiah? Hey.
Teacher, let me try that.
Isaiah, are you there? No. Okay. I want. Namukasa Ruth.
Question.
Namukasa Ruth, are you there? Ruth? Ruth, are you there? No.
Yeah.
Ruth?
Out
Okay.
of the answer is 2.
Okay. Chirabo. Chirabo, are you there?
Yes, teacher, I'm there. Hello, teacher.
Chirabo, can you solve for us this using the
Yes.
principles of
The
principles of addition?
Of addition. Okay, the 7 out of 8 minus 3 out of 8 is equal to 7, 8, 5. Is equal to 5.
What do we do?
You find the find the lowest common factor, but since the denominators are the same, you just get 7 minus 3, then out of 8. You get 7 minus 3, then you divide by 8. Minus 3. Minus 3.
Minus what? Minus 3.
3.
Mm-hmm.
Divide
Out
by
of
8. 8.
Divide by 8. Here?
Yes.
What shall we get?
We shall get 4. We shall get 4 out of 8.
Out of?
8.
Out of 8. Uh-huh.
Then we simplify it.
Simplify it. We shall
get
what?
1 out of 4.
1 out of 4.
4. Yes.
Thank you. Thank you very much. Now, members, as we said, we are using the same principle as addition. Maintain the denominator, okay? And then carry on the subtraction for the numerators. Simple as that. That's what we are doing. Okay, let me invite questions. Letitia? Letitia? Letitia, are you there? No. Innocent? Yes? Innocent S?
Yes, I'm hearing.
Yes, your hand is up.
Yes, the answer is 1 out of 2.
Uh-huh. So the answer is supposed to be 1 out of 2, not 1
2.
out of 4. Okay.
Yes. Yes, the answer. That's the answer.
1. Good. Thank you. Thank you. That is what people are saying. When you reduce.
You are welcome.
Okay, it is 1 out of 2. Anyone else asking? Walter, Mayanja Walter, are you asking?
Teacher, I only have a correction. So the quotation mark, the equal signs are not supposed to be in the same line. You put them in the same line, but as in the math law says they are not supposed to be in the same line.
That's very true. This is just for illustration here.
All right.
Okay? Yeah, this is for illustration. Thank you. Chirabo Drusilla?
Teacher, I was saying I can get you. Teacher, we are not allowed to put the fraction in its lowest terms unless we are told.
Now, when you are trying to solve this, okay? Remember I told you earlier on, when we are doing the conversion, when you're converting something, you do not reduce it down. Okay, but here we are trying to add and then we are getting something, meaning that there is no way you get this half here and you prove it back to this one here. Okay, you'll not get it and then prove it backwards, but instead you get a final answer. Okay, that is what we are looking at. So that's why when you reduce it down, there's no problem. When you're adding or subtracting, it is okay. Okay, when you're adding or subtracting, it is very, very fine. Okay, so members, that is subtraction. There's another thing. What happens when you're subtracting, but you're subtracting different denominators? When we are subtracting different denominators, take an example. We have this. I want someone to do for us this one here, and I'm going to pick on someone. We are going to, now this one also, we are using the same principle as adding, okay? Same principle as adding with different denominators, okay? Adding with different denominators. Can I see someone who is ready to send a message in the inbox? Then I choose you from there. Send a message from the inbox, the first person. I want to see the first person. Send a message in the inbox if you're ready to work out for us this one. I'm waiting. No, just send a message because some people's hands are up and they are not ready to say. Okay, proceed, and who? And family. Okay, proceed. Proceed was the first. Proceed and family.
Yes, we get, for me, I do it like this.
Yes.
I get 11 into, and that is 22.
You do what? Pardon.
Get the LCM.
I guess the LCM.
I get the LCM, I take it as 22.
Your LCM is 22. Okay.
Then I say 22 divided by 11, that is 2, then times 6.
2.
That is 12.
Times 6, then it is 12. What?
Then 22 divided by 22, that is minus 22, you divide it by 22, 1, then times 3, that is 3 again.
Which gets 3, what?
Then
plus
12 minus 3, that is 9 out of 22.
Out of 20.
Yep.
Thank you very much, person. Okay. Most people have even got their answers here, but such has got it good. So, members, when we do that, we are still following the same principle. So, in addition of different, we use the LCM. That is what we used. Okay, and also here we are using the LCM as well. That is what we are using. Is someone having another method? Can I have another method? Send in a chat if you have another method. Send your message in the chat if you have another method. Send a message if you have another method and just talk to us. We are all having one method. Please send a message. Send a message. You say, me, I have another method to come up with the same answer. Yes, this is a someone telling us this is a Martha. Are you Martha? Are you there, Martha? Martha, are you there? Can you give us another method? Hey, are you there, Martha? Speak to us. Okay, she's not there. So, but Martha is telling us to use cross multiplication. I want Martha to tell us about the cross multiplication. How she's going to do it. Where is Martha? Martha.
Teacher Jones.
Yes.
Teacher Jones. Yeah, I love Martha's method because I've ever used it. Initially, I did not know until one time I watched from YouTube. So this is the way it will be. Okay, you
Good.
first cross a line. First put a line.
We are crossing the line.
Okay, you cross multiply 6 by 22. That is numerator.
6
by 22
times 22. We put it
yes,
up.
you can, yes, or in brackets, yeah. 6 by 22.
22 in brackets. Okay.
Subtract.
Minus.
11 by 3.
11 times 3.
Out of now that 11 by 22.
Out of 11 times
by 22. Yeah.
Good. I think this is I think that was terrible. Who had given us the same thing. So class, the other one that we're talking about the cross multiplication. You multiply the 6 by the 12, the 22, and also the 11 by the 3 out of this one, the 11 times the 22, and you come up with your answer. So when you multiply this and then carry on the subtraction, you will come up with the same answer. Where is Opio Isaiah? You have a question. Opio Isaiah. Isaiah? Opio Isaiah, are you there? Okay. Adele Treasure. Adele Treasure. Treasure, can you unmute and tell us your method?
Sir, I want to just ask.
Yes.
If I use the same method I used when adding, do I get the same answer?
You tell us. Share with us. Share with us how you.
That is times 22.
You said?
Times 22 brackets.
6 times 22?
Yes. Then minus 3 times 2.
Can you start afresh? Can you start it again? 6 times
22.
Your network is
the
not
method
clear.
of
Can you?
Times 22.
Are you talking about this method we have here?
Okay, Teacher Jones.
Yes.
I think you first simplify that answer so that they can see whether it works.
Okay.
So let's get 6 by 22. Let's first get it. Let me check it here if I have my calculator.
Okay.
Round. Yes, let's first simplify. Okay, so 6 by 22.
6 times 22, that is 130.
You get 132.
132 minus
minus 33.
33.
Let me see, 11 times
out of
22. You get 242.
This is 242.
So let's subtract 132.
This will be 90.
Yeah, I think minus by 33 is 90. Yeah, true.
Is it 99?
No, 99. Yeah, 99.
99
out of 242.
242.
Yeah.
So we reduce it down. Aha. Can I have Adele? Adele. Chirabo, are you there? Yes, Chirabo. Chirabo?
Excuse me, teacher. Yes, teacher, I'm
Yes.
there. What if I get?
First, hold on. Can you first simplify for us this one here?
Okay, by 3.
By
That
3.
is 33.
33.
Yeah.
Out of by 3.
Then by 3, that is 40. Let me see. 3, 6, 9, 10, 12, 11. That is 8. I really don't know. 81. 81.
This is 81. Sure.
It's not divisible.
It is not.
It's not.
It's not. It is not by that. Okay. It is not.
Okay,
by,
but I had another method.
I
had another method for that answer.
You share
for that
with
question.
us.
Okay.
You share
Okay.
with us.
Okay, like teacher, if I get 6 out of, we have 6 out of 11, then minus 6 out of 11 minus 3 out of 22, then I put in brackets, I put 22 times 6 out of 11. Excuse me, teacher.
22?
22 times, yeah. That is
22.
like 22 then in brackets. In brackets, 6 out of 11.
Can you start it afresh? Can you start it afresh? For us, we all say.
22 in brackets, 6 out of 11.
In
Then
bracket 6.
Out of 11.
Out of 11.
Then minus times 22.
Times
No,
20. Minus.
Minus, yeah, minus.
Minus
3 out of 22.
3 out of 22. Into
Then
brackets.
times 20. Yeah, into no times 22. Yeah.
Times 22.
Yeah. Then later on I go to that 11. I reduce by 1. Then also by 22 it becomes 2.
This is 2.
Then by 22 there, where there is 3 out of 22 by 22, 1, both sides.
This is 1.
So there I'll get 2 times 6 minus 3.
Sort of minus 3.
Generally it's sure of minus 3. But then I forgot to tell you that we are supposed to divide. Okay, that's how I wanted my method.
By 22.
By
okay.
Yeah. Then afterwards I get 9 out of. Then I get 9 out of 22.
9 out of 22.
Yes.
Now, so class, this is the point is, let's get here. To avoid the mixing up the bit of the numbers, it will be more wiser to find the LCM. Okay? It is more wiser that we first get the LCM of the two numbers. I told you the other thing that we were doing, we can also make the denominators the same, and then we get with the other first method of leaving the denominator the same and then subtracting. So, but if you know that, for example, we said let's maintain the LCM. Okay, when you maintain the LCM, here we know the LCM is 22. Okay, once you know that, then you can go ahead and carry on the subtraction. That is what I would like us to pick on from. So take an example. If you look at the other first method here that we used, remember, if we want to make these ones the same, if I want these ones to be the same, I can multiply this one by 2 and also the upper one by 2. Look at my simplest way that we can do this. Remember the other one I told you that we can try to make the denominators the same. We want these denominators the same. How do I make this one to appear like 22? Remember, it is the largest one. So we shall get here you will end up having 22 now out of the what? Out of the 12. Now, once you already have this, you now subtract directly. So at the end of it all, you have this 12 minus the 3, which is the 9 out of the single 22 that you have. So I want us to look at these two things clearly. The LCM is more important. That's the very first one. But if you would like to work out this one using making sure that we make sure our denominators are the same, so that we use the other first method of the same denominators, then we maintain this. So you just ensure, because if you want it to be the same, we can utilize this as well. While another person might also say this one time was 22, then this one also time was 11, then the other one time is 11. It is the same thing, but you end up having a very larger number to reduce down. Okay, so the other methods you know, some methods will work on a certain number, others will not work on a certain number. But the universal ones, you'll see that you keep, like the LCM. The LCM will keep working everywhere, wherever you keep on meeting it. Now we are going to see so many numbers in the same process. So I said method 1, use the LCM. Method 2, the other one we call the LCD, whereby you say make sure the denominators are the same. Multiply by a certain figure. As long as when you multiply, please multiply both down and up. Don't only multiply down. If I want this 11 to look like the 22, I should also multiply up. Remember, I've increased both the bottom one and then the upper one as well. So you have to increase both of them. Don't increase only one. Increase both sides, and then you come up with the answer. Okay. Now that is with the subtraction of fractions with the same, sorry, with different denominators. Now, what happens when we are dealing with the can we also use the method of equivalent fraction? I think this is the method I've told you about. Okay. That's the method of equivalent fractions. This is the the one of multiplying is the one for equivalent fractions. The principle of equivalent fraction is we are trying to make sure that the numbers are the same. Okay, and to make those numbers the same, we multiply both the denominator down and then the numerator to come up with that. It is the method of that's the method of the where is the 2 coming from? The 2 is ensuring that we are not having the 22 down. Okay, let me move back a little. Here. Here. Where is the 2 coming from? We are ensuring that we have the same denominator. Alternatively, someone can also, we are using equivalent fraction. You remember, there is a topic of equivalent fractions. The part of equivalent fraction, we are trying to make sure this fraction is the same as the other fraction. That is what we are looking at. So that is the method we talk about. Now, then you were saying 99 by 11. The other method was the other one of the one where we had 99 out of 242. Here, the reduction is we reduce by 11. This will be by 11. This will be 9. Okay, reduce by 11. So this will be 9 out of by 11. We shall have 22. That's how we will get this. The other one, remember the other one we're working out. Yes. So we will move to that given part. Okay. We proceed with this part of we are continuing addition of mixed fractions. Now, when we have mixed fractions and we are adding them, okay, when we are having mixed fractions, is someone still stuck here? Is someone who is still stuck here? This one here, remember, this one here, this is what we did. We are reducing 11. When you get 11 times 9, 11 times 9 is 99. Eh? Okay, and when you get 11 times 22, you come up with 242. Try checking your calculators. Eh? You'll come up with this. So later you can use that method as well. Okay. All right. Now when you have mixed fractions, finally, what do you do with mixed fractions? With mixed fractions, for example, this one here, when you have such a fraction, now this one is the simplest if you have, for example, you have this is a whole number and then this is a fraction. Okay? A whole number and you have a fraction. What do you do? A whole number and then the fraction. Melody. Someone called Melody. Melody.
Excuse me, teacher. Excuse me, teacher. I'm still stuck on the other first part. I'm still stuck.
Where are you stuck from?
Where you say that it was 3 times 2 out of 6 times 2.
We are using the principle of equivalent fractions, where we are making sure that the 11 is the same as the 22. That's why we are multiplying by that. Okay? That's why we are carrying on that multiplication. Okay. Let me request Chisache. Melissa is not spoken today. Melissa? Melissa? Oh, Melissa is not there. Okay.
Yes, teacher.
Can you work out how do we work out this one here?
Teacher, we give 3 1. We said 3 out of 1.
3 out of 1. Plus
Then we
7
find
that's
7 out of 8. I was giving the question, you first answered first. That what do we do when 3 doesn't have anything?
Then afterwards you solve it.
Okay. Let me see. 3 out of 1 times. Let me first work it out.
Hey, who has got the answer here? Who can give us the solution here? We are going very fast. Sozi. Quick.
Yes, teacher.
Chap.
We say 3 out of 1 times 8 into brackets plus into brackets 7 out of 8 times 8 over the 8.
We are here now. How do we do?
Over the 8.
Over the 8 here.
So by yes, you can. So 3 out of 1 times 8. We are dividing. We cannot divide 8 by 1. So we go on 8. Divide by 8, which is 1. Yeah, are you hearing?
I'm not getting your answer very well. Your explanation.
So out of 8. So we get the 3 plus the 7 out of the 8.
Hey, we just get, but remember here we have a different fraction. We said this is now a different fraction.
Yes.
Chirabo, you've gotten the answer. Elizabeth, I've seen your answer there. Chirabo?
Yes, teacher. You get?
Yeah.
Yes. So like since 3 is a whole number, you change 3 into you make it out of 1 to make it a fraction. So you say you say 3. Okay, you get the 8. Then you say 8 divided by 1. it's 1. Then 1 times 3. Then 8 times 3. 1 times 3 is
8 divided by 1, you're getting?
8 divided by 1. It's 8. It's 1.
1 or 8?
It's 8, sorry.
8.
Then 8 times 3.
Mm-hmm.
It's 24.
24.
Yes. Plus 8 divided by 8, it's 1. Then 1 times 7, it's 7.
7. So which will come to 30.
31 divided by 8. Since 31 is greater than the denominator,
so
you
what
say
is it?
3 whole number.
3 whole number.
7 out of 8.
7 out of 8.
Yes, teacher.
Good.
Yes,
Now,
teacher.
class. The point is, you see, when you have such a number like this, this one is automatically you saying 3 whole numbers, 7 out of 8. It is like they are giving. It's like an example. Let me give you an example. If you have one chapati, let me use that, and me I give you a half of it. I give you a half chapati. How many do you have? You have 1 chapati and a half. That is what you have. Now, this is what we are trying to locate here. If you tell me you have 3 slices of bread, you have 3 slices, and I add you another half, I give you another half, you automatically have 3 slices and a half. Okay, so let's not stress ourselves so much. But when we are to show the working, if you're told to show the working, this is how the working shall be. But in your mind, you should be knowing, once I have this one, automatically I know my answer is 3 and that. Okay? Okay, that is what I want us to look at. That's what I want us to see when we are working with the fractions. Okay, so when you have the mixed fractions, that is how you're going to work it out. So as we wind up our class, this is what now when you have this. So what happens when you have these 2 mixed fractions? Step number 1, change these ones into improper fractions. Okay, change them into, these are mixed fractions, change them into improper fractions. After changing them into improper fractions, then you use our principles that we have used for addition. We use our principles for adding and then subtracting. Okay? That is what we are using. So if you have this, turn this one into an improper fraction, which will be 3 times 5 plus 2, which will be 15. That is 17 out of 5. Okay, plus the 1 times 7 plus this, which is 11 out of 7. Okay, then you try to continue with your addition and subtraction. So class, this is what we are going to keep on doing. Okay, our time is fast spent. Now I have some more exercises for you that I'm going to post for you. I think we'll see it here. We are going to work out this exercise. I'm going to post it on our Google Classroom, and then we see how we can work it out. Okay, there are so many of them, but try to practice through, and then you will work out all of them and see how it will go. Okay. Okay. Now, class, also there is something that we are going to. I want you to go and visit this place here where we have more questions. Let me share with you something. I don't know if you can see this. Let's get to our, I don't know, there is that link there. Okay, this is it to everyone. Do you see that link? I think you've seen that link in our chat. Now, I want to, that site has so many questions and quizzes for us about math. Now, this is how we are going to access it. I don't know if you can be able to see here. this one. Okay. When I get it, I will. But the point is, you go and tap it, or you copy it somewhere, and it will lead you to somewhere where you get most of those questions there, and you work out even some quizzes, and then you share. You share with me the answers, and then I'll be able to check through them. Okay. All right. Our time is fast spent. Thank you so much for being part of the class. And I want to welcome, please make sure you hand in your assignment so that we can try to work it out together. Maybe one more question, Miriam? Miriam, someone with a question? Okay.
Yes.
You have a question? No. Okay. Otherwise, thank you so much for attending, and I wish you a nice week. Please work out those assignments, and then we shall be able to. I'll be able to check through. Okay. In the case of anything, please you can always contact me so that you can work out the items together. You can always contact me, and then we can work out together. Thank you so much for attending, and I wish you a good day. I've sent a number there, so you can contact me through that number that is there in the chat. Okay, thank you so much.